So for question 7, we're starting off with a precedence table, and it's got to do with the manufacturing of masks. The first part of the question wants us to then fill in the corresponding network because there's 2 boxes that need completing. So to do that, what we are looking at here is we're going to be looking at where these tasks point. So you can see that this one, G, it requires whatever's in this first box to be completed first as a prerequisite. So when I go and have a look at G, I can see that an immediate prerequisite is D, and so that's what I know needs to go in the box. A similar thing for H, I can see that my missing box here, or my task for my missing box, goes into H as well as D. So when I go and look at H, I can see that I've got D and E here. So I've already accounted for D because that's coming down through my dummy link, but I need a D as a prerequisite as well. Part B is saying, can you explain why the dummy link on X is required? So there's 2 dummy links in this network, but we're only explaining X. And we're going to explain it in terms of having a look at a couple of tasks and what the prerequisites are for it. So we'll start with task C, which is down here. And I'm going to say that task C requires both A and B to be completed. A and B. Okay, and then we're going to switch over here and we're going to have a look at what's happening with D and what's happening with E. And we're going to say that but task D and E only require task B to be complete. Okay, so again, just going back to our diagram here, we've got B coming through. D and E need only B and B only, but task C down here needs both A and B for it to come down and then go. So task C requires both A and B to be completed, but then task D and E only needs task B. So you've got to talk about both of these. Moving on to C, it's saying which option below correctly identifies the critical path and minimum completion time for this project. Now, critical path, it said before you shouldn't need to complete a forward scan or backward scan for these. So which means we have to get the answers from our table. So back on our table, I want to look for ones where the earliest start time and the latest start time are the same. So here I've got the same. I've got the same here, 6 and 6, and keep going. I've got these 2 are also the same. So because they're going to be the same means that they have to be on my critical path. So just looking at my nodes there, or activities, sorry, it's going to be task B, E, H, and J. So when I come down here, I'm looking for B, E, H, and J, which is this one or this one. And then I just need to find what my minimum completion time. So I'm going to go to the task time that it has, and just going through that list now, I can see that it's going to be 6 for B, 6 for E, 5 for H, and then J was going to take 2. So I've got 6 plus 6 is 12, plus 5 is 17, plus another 2 is going to give me my 19 hours. And then there's another multiple choice kind of question here. It says, which of the following statements, so it doesn't just have to be one, are appropriate. So you're just going to go through and either rule them out or maybe they're a possibility. So task J will always be on the critical path because it takes the shortest amount of time. That's no reason for it to be on the critical path. You can see here that task J is on the critical path because it's the one that has to be done before everything has to be finished. So that's not really a reason. That's not a cross. It's a cross. Task A has no slack time. So if we're looking up here, this is where we're finding our slack time. Task A we're going to have 1 take 0, which equals 1 hour. So it's got 1 hour slack time. So that one is not possible either. Task J will always be on the critical path because it's the only task leading to the end of the network. Well, we just seen that before above. We said that was why it was on the critical path. Dummy link Y takes more time to complete than dummy link X. They both have time, both have 0 time. Remember, it's not really an allocation, it's just a direction of your resources. A delay of the completion of J will always increase the minimum completion time. Well, that has to be true because it's always on the critical path no matter what. So those two are going to be your correct answer there. So for question 8, we've got another finance question. This time we're taking out a loan for a small apartment. So Olivia's borrowing $280,000 and it's going to be for 15 years. Now there's a couple of different options available to her. And in part A, we want to know what's the comparison rate for option A. So what is it that nominal rate adjusted to if we have to kind of consider all the fees associated with that loan. Now it is a compounding fortnightly account, so we have to make sure our PY and CY are 26, and then because it's 15 years, N is going to be 15 times 26. The loan itself is at 3.89% per annum, and then our PV is going to be equal to 280,000 plus 1,500. Payment is what we're going to find in order to pay this loan, and then the future value, we want it to be 0 at the end of the 15 years. Going to the graphics calculator, we've got apps, we've got finance, we've got that TVM solver. So 15 times 26 is the N, 3.89. Our PV is going to be 280,000 plus 1,500. The payment itself we're finding is 0, future value is 0, and then it's already set to be 26. So we should just be able to go alpha solve, and we should see here that we are going to pay $953.27. Note that we've rounded up so that we can actually have this all paid off in the required amount of time. Now that's to take into account for the establishment fee, but we do have this ongoing service fee as well, which is $15 per fortnight. So just coming over here, just really quickly, we need a new payment. And that's going to equal 953.27 plus 15, which happens to be 968.27. And so we'll put that in to start with. Remember, it's negative because it is a payment, 968.27. It's still going to be the 15 times 26, the 26 being the fortnightly period. The I is what we are now finding because that's our comparison rate that we're after. That will count now for both the establishment fee as well as now the ongoing service fee of $15 per month. The loan is going to be just the 280,000, and the future value will be 0. So we'll just kind of make those changes. So PV is 280,000, and then this one down here is negative 968.27, and then we're solving for the interest. Again, you don't have to zero it off. I just do that first. So we've got 4.20% comparison rate. Okay, now let's see what happens down below when we get here. So now it says, which statement most accurately describes the best option for Olivia? Tick the appropriate box. So it's only one box to indicate your answer. And it's got to be down here. It's got to be that option A is the best because it has the lowest comparison rate. So we're really comparing here the 4.2, and then we're comparing that to option. Okay, and compare it to 4.25. So you can see that 4.2, which is option A, is less than option B. Okay, then we come down here and it's Olivia chooses a different option. And in this one, she wants to pay a deposit of $50,000 first to take out the loan, and then her weekly repayments are going to be $396 for the 15 years. Okay, and it's a show that question, so that we want to get to that 4.1% per annum compounding weekly. So going in here, it is compounding weekly, so we've got our 52. It's for the 15 years, so it's 15 times 52. The interest rate is what we're trying to find. We've got the 280,000. But then we're going to subtract out that deposit. So subtract the 50,000. The payment says it's going to be 396, so that's got to be negative. And again, it's a loan, so we're going down to 0. So 15 times 52. Interest rate is the option to find. We've got the 280,000 here, but then we're going to minus 50,000 for the lump sum. The repayments are going to be 396, and then it's going to be weekly, so we're going to be coming down to 52. Solving for our interest rate. Alpha solve, and we can see here that it's approximately 4.1. So we'll say that I is equal to 4.142. Remember, we need to say that one first before we actually say that it's approximately equal to. So I'm going to say the interest rate is equal to 4.142, which is approximately equal to 4.1%. Okay, so that's the different option. So she's trying to save money by paying a lump sum. Then we come down, it says calculate the time it will take for the balance of the loan to reach approximately half of its principal value. So the future value here is going to equal the 230. Then we're going to divide by 2 to give us 115,000 in here. So the n is what we're trying to find. We've got the 4.142. So again, I didn't use the approximate value. I've used the actual one we calculated. We've got the $230,000 loan. Sorry, I can't really fit this very well. The payment is going to equal minus 396. And the future value is the one we've just shown above. So it's going to be negative 115,000. And the PY and the CY is going to be 52. So we'll come up here, we're solving for n 4.14, that's not a 4, 4.142, 230,000 is fine, that's fine. The future value here is going to be minus 115,123. And we'll see what our n gives us. So I was saying it's going to take 4, so therefore n is equal to 449.6 weeks. Okay, now we have to consider the next little scenario. So we've got when the balance of the loan is reduced, so we've got down to 115,000, we get an inheritance which allows her to pay off the loan in full. However, there's still going to be 2 options to consider here as to which option is really better. So option X is we can repay everything in full. Okay, but that means that you have to pay an early repayment charge, so we've got to pay 11% to cancel that loan, I guess. Or we can refinance the loan for 6 years with interest charged weekly at 3.5%, compounding interest charged weekly and then compounding weekly with no additional charges. So let's pretend that we do option X, repay the loan fully, and so we pay that 11%. So our early repayment is going to equal the 115,000 times 11%, so times by 0.11, which is going to be, let me just quit out of here, 115,123 times 0.11. Which is going to be 12,650, so $12,650 to do the early repayment charge. Okay, then we're going to consider the other option, and then we're going to compare which one seems better. So we want to calculate the total interest here that Olivia will be charged if she chooses Y. So again, we're going to have two different ways of calculating this, and I'll do both because, again, I know some of you will prefer one method over the other. So we're going back up to the question. We're compounding weekly. So we've got PY and CY is the 52, and we're going to do 6 years. So 6 times 52. We have 3.5% interest. We've got 115,000 left on our loan to pay at this point. We're going to find out what those payments are, so then we can calculate the interest, and then we're going to have this 0 repayment here. So if we go apps, finance, TVM solver, we've got 6 times 52, 3.5%. We got down to 115,000. Payment is what we want. This time we're going to 0, and we go alpha solve. So it's saying that we've got 408.76. We always round up to 7 in this case. Now the last little bit of this calculation is the interest. So the interest is going to equal, again, our payments times times the number of time payments that you did, and we're going to take away the present value. So we're going to go with 408.77 times by, I think it's, hang on, let me just put it, it's up there. So 312. We're going to minus our present value, which is 115,000. So in our calculator, it's 408.77 times 312, take away 115,123 zeros, and we end up with 1,256. 12536.24. Okay, now that was one way of doing it. If you want, though, you could do it the sum of int. Okay, again, we're going from the first period down to the 312th period. And let me just quickly make sure we've got the right thing happening back in here. We've got 312. Just change this to be 7. It's got to be the rounded number. Go back in again. Apps, TVM solver. Just get rid of that last one. Okay, so that's all set up. So then when you go back out here and then you go apps, finance, and then we go down till we get to that sum of int, we can do the 1,312, close it up, and then we get 12,535.83. So either method is fine. Just have to be clear, obviously, which one you're doing and which one you prefer. I have pre-filled this one again for us. It says, just going back to the question, it says state 2 reasons to explain why option Y. Oops, chooses option Y to deposit the money into an offset account linked to the option. Okay, sorry. So firstly, option X is $113.76 more expensive. Okay, so if we shut down the loan straight away, we pay a very expensive closing fee, and so that makes it a little bit more expensive over time. An offset account, having access to that means that she can withdraw money if she needs it. The interest rate in option Y is at a lower rate than the original, so it's 3.5 now compared to the 4.1% originally, so we are making some progress there. And then the last one, you could have said, again, you only need 2 of these. The offset account will reduce the interest paid, thereby reducing the cost of the loan. Either of those are acceptable, just choose 2. So looking at question 9, we're doing another regression question. This time we're looking at time after medication is administered, so it's medication B, and then the concentration of the medication in that particular bloodstream. And we're going to start off with the medication that is called V. So they give you the data. Also given to you is the residual plot for the linear model, and then you can see here they actually give you the linear model as well as the R-squared value to start you off. So it says, using the information above, explain why the linear is not appropriate for using for use for making predictions on this data. So the first thing I'm looking at is these numbers. Numbers here, and they're quite large. So I'm going to say high residuals. Or residual values compared to the data. Okay, so we've got data. You can see there that is, in the 300s, 31s, etc. But then we've got this massive residual values as well. And then also looking at this, we can see that we've got this pattern thing happening as well. So I'm going to say there is a pattern in the residuals. Okay, and that's the reason why it's not appropriate. So it should be, you don't have to write this bit, so it should be randomly scattered if it was linear. So that's just using that information that we provided. So then the next part of the question is this one here, where they've decided to fit an exponential model to the data. And let me just get my red pen. This is the one that we've got with. So it's C is equal to 962 times 0.89 t. Okay, so there's a bit of a multiple choice question here, and it's asking you to interpret the value of B in the context of the question. So B is this one here. So what does 0.89 actually mean? So it's got to do with your growth or decay rate of the exponential function, and it's actually, you can tell what that rate is by saying, because it is a decay, it's going to be 1 minus the 0.89 times by 100, which is going to equal 11%. So it's saying it's decreasing essentially by 11% per hour, and it's medication V. So I guess it's going to be this one down here. Okay, and then we move on to talk about A, and A is going to be 962. So why is that an underestimate of the original data? Well, this is the initial concentration. So we're going to compare the 962 to the actual original data. So I'm using the model. When t is equal to 0, C is that 962. However, using the original data, when t equals 0, and let me just check this, double check. Oh. We get 1,000. So C equals 1,000, which means that this is an underestimate. Okay, so now we're actually going to use the model given to us. So using this C equals 962, we want to calculate the concentration. Okay, so the concentration here of this medication 24 hours after the medication was actually administered. So we're talking about hours, so I'm going to just write here that T is equal to 24. So therefore my concentration is equal to 962 times 0.89 to the power of 24. So 962 times 0.89 up to the power of 24. And that's going to equal 58.6, what is that, 69 micrograms per mil. You could also use that, get that same information from the graph if you graphed it and use your value command. In fact, we might do that because we're going to be playing around with that anyway. So the other way you could do it is going to y equals, you're going to write 962, you want to put the equation in, so 0.89 up to the power of x. Going to graph that. Now it may not look so nice here, so you can go into the window. You know what's happening on the graph here because you know your x-axis is going from that 0 to 30, so you could take it out maybe to 50, just extend it a little bit. Your smallest y value in the table was 31, so you could probably start this off at 0, and the largest value was going up to 1,000, so we might just go up to 1,000 for this one and then graph it to see what's happening. Now, to get that concentration after 24 hours, you can go into your calc. You can go value, so press number 1, and the x value is your 24. And oh, that's not quite right. Hang on. Oh, it's because I did 600, so there should be 962. So let's just quickly graph that again. So much better. Now go second function calc. Go value, and then when we go 24 this time, we should get the 58.69. So that's another way of doing it. It's only 1 mark, so that would be fine. So we've got the concentration this time. So C is equal to 481, and we want to know what the actual time taken there is. So we've got 481 is equal to 962 times 0.89, and we're interested in getting that t value. Now the way that we're going to do that on our ti is we're going to go back into y equals. We want to put the line of 481, and we're going to find where these guys intersect. So second function calc, we're going to go down to number 5, which is intersect. They're just going to press enter twice because they're just selecting the 2 lines you want to find the intersection of, and the guess, or it will give you a reasonable guess regardless. So we've got t here is equal to 5.95, and it must be in hours. Maybe I'll just fix that up. And that's it. So moving now to the last page of this exam. This is a different company. So now we're not talking about medication V, it's now medication W. And I've got a new exponential equation to describe that concentration over time. Calculate the time taken for this concentration in the bloodstream to reduce also to that 481 level. So C again is 481, but this time it's going to be 481 is equal to the 970. Oh, so the new model times 0.75 to the power of t. So we just have to go back in. We've got a couple there. We could just turn that one off. And then over here, we can, in case we need it again, although I don't think we do. That was 970 times 0.75 to the power of x. And then we graph this one. And we're going to do the same thing we did before. We want to calculate that where it intersects, that line intersects. Just enter, 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 so 3 times. And this time we're going to get that it happens after 2.44 hours. All right. So let's just have a quick recap. So this one was 2.4 hours, 2.44 hours it was going to take to get to that 481 concentration, whereas up above, well, it's going to take us 5.95 hours. And I think we're going to be comparing these underneath. So, okay. So it says a reference to the parameters of the model. So the parameters are your A and B. Explain why there is a difference in the time taken for the concentration of the second medication to reduce to 481 compared to the first medication. So why is there a difference in the time taken? So you're going to be comparing your decay rates here. So you could start off by saying medication V, which is our first one, reduces at 11% per hour. So we did that calculation earlier. And W reduces at, and what was that? This one looks like 25% per hour. So just in terms of that, how to get that 25%, it's going to be 1 minus 0.75 times by 100. And that will give you 25%. So that's kind of like what's happening. So you can see that W is reducing at a lot faster rate per hour. So we'll just write down that W, now we know what the decay rates are. W reduces at a higher rate than V. Therefore, W will reach 481 micrograms per mil faster. Yeah, that should be enough to get you your 2 marks there. And that is the end of the exam.